sulfonic acid is the product, main product, when the benzene undergoes sulphonation. So that means here the replacement of hydrogen atom in the benzene, by the sulfonic acid, this is the sulfonic acid group SO3H, sulfonic acid group is SO3H, in a ring is called sulphonation. That means when benzene is treated with the sulfuric acid, is said to be sulphonation, we say, which is an example of electrophilic substitution reaction. That means when benzene is heated with the fuming sulfuric acid, is said to be sulphonation, we say. Let us look into this mechanism of this, what mechanism is involved in this. Same mechanism what we have seen in this electrophilic substitution reaction mechanism. So, and in this, now let us look into this mechanism. So how the mechanism goes in this sulphonation. The mechanism is associated here is that the mechanism is simple electrophilic substitution reaction, and the first step, in the step one, again generation of electrophile. In the step one, generation of electrophile is there. The electrophile is, what is the electrophile here is that, sorry, so the electrophile is the main electrophile that is generated in this reaction is that sulphonic. This is the electrophile is produced, SO3 plus H electrophile, the strong electrophile. This is how this is produced. We can say here, when benzene is treated with this fuming sulfuric acid is available in the form of oleum. So oleum formula is H2S2O7, or else, so we can take 2 moles of sulfuric acid. If you take 2 moles of sulfuric acid, if you take in that, so one sulfuric acid molecule act like acid, other sulfuric acid act like the base, then there could be protonation. So when protonation is done between the 2 sulfuric acid molecules, so one will be produced sulfonic acid, other will be bisulfate ion we can get. So if you take sulfuric acid, or we can explain this like this also. But this is the sulfuric acid molecule. When SO3 gas is passed into this sulfuric acid, we can get oleum by the protonation process. This SO3, the pi bond is given to this proton. This is called protonation. The lone pair is given to this proton. Then sigma bond will convert to negative charge. The bond is broken here. You can see. When this proton is given to this, when the proton is added to this, so then this molecule become into electrophile because the positive charge is produced on this sulfonium ion. This is called sulfonium ion. This is sulfonium ion is formed. This is bisulfate ion is produced here. That means sulfonium ion is the electrophile. We say sulfonium ion is the electrophile. The sulfonium ion attack the benzene. Look at this. This is the benzene. When electrophile is added to the benzene, pi electrons. Then there is a bond formation between sulfur and this carbon. And this, that means, so once the the pi electrons given to the sulfur here, there is a bond between sulfur and this carbon. There is a positive charge is created on the carbon, on this carbon. Then this is said to be what we call means carbocation of sulfuric acid. The carbocation is reaction intermediate is formed here, and this reaction intermediate undergoes resonance forms, different resonance forms it undergoes. So the pi electrons delocalize within the ring, the positive charge shift will be there. So on the para position now, so again the positive charge shifting to the ortho position here you can see. And when the positive charge after delocalization, then the sigma bond is converted into pi bond. Sigma bond is converted into pi bond here. And this hydrogen, the proton, is abstracted by that base or nucleophile. This nucleophile abstract this proton. So then when this nucleophile abstract this proton, the sigma bond is converted into pi bond, then we can get benzene sulfonic acid we can get. This is hybrid resonance hybrid structure. Now at the final step, look at this, the hydrogen, between this hydrogen and carbon, the sigma bond is converted to pi bond. This proton is taken by this bisulfate ion and forms into again sulfuric acid is produced. Sulfuric acid so is produced back here, this is, and we can get benzene sulfuric acid is the main product is obtained in this mechanism. So, since sulfonic is a electrophile attacking this nucleophile called benzene, and by replacing the hydrogen atom is said to be electrophilic substitution reaction. Sorry. That means electrophile replacing the hydrogen atom present at the benzene is said to be electrophilic substitution reaction. This is said to be sulphonation, we call. It is said to be sulphonation. So in this sulphonation also, generation of electrophile sulfonium ion, attack of the sulfonium ion on benzene. Third step is deprotanation. That means electrophilic substitution reaction can be explained in 3 steps. Number 1, generation of electrophile. Number 2, attack of the electrophile on the benzene. Number 3, deprotanation of the benzene, and to form the final product called benzene sulfonic acid. Benzene sulfonic acid. So now let me discuss about another example for electrophilic substitution reaction is that Friedelcraft alkylation. The Friedelcraft alkylation is also comes under electrophilic substitution reaction. So when benzene treated with this alkyl halide in the presence of anhydrous aluminum chloride, so here is so anhydrous okay, so there is a smelling mistake. And now when benzene is treated with this alkyl halide, so in the presence of anhydrous aluminum chloride, so then alkyl benzene is formed. Alkyl benzene is so produced. Alkyl benzene is formed here. Now let us look into this reaction. This is the benzene and react with the methyl chloride. So in the presence of anhydrous AlCl3, so then we get toluene or methyl benzene we can get. HCl is the byproduct. The same mechanism, so when this methyl chloride bond is broken heterolytically, the chlorine get the negative charge and the methyl group get the positive charge here. Electrophile is the methyl and this chlorine is temporarily bonding with this AlCl3 and AlCl4 is produced, then methyl group attack this benzene. Methyl group attack the pi electrons here. This is methyl group attacking this benzene, then methyl benzene banega. Similarly, when this ethyl chloride also react with this benzene, and here there is a heterolytic fission takes place in the presence of this Lewis catalyst, and the Cl will form this negative charge and ethyl will form the positive charge. Then the Cl and temporarily bonding with this AlCl3 and AlCl4 is produced, then so pi bond of the benzene So given to this, pi electrons are given to this ethyl carbocation to form ethyl benzene. This is said to be so Friedelcraft alkylation means so benzene is alkylated, or benzene means react with the alkyl halide and forms into so ethyl benzene we say. Similarly, so there is a Friedelcraft acylation also there, similar mechanism. And in this, so benzene is treated with acyl halide, which is called ethanol chloride. This is what we call means acyl halide is IUPAC name, ethanol chloride we say. In the presence of anhydrous Lewis acid LCl3, so and produces acyl benzene, ethanol chloride will get the same mechanism. So and in the presence of AlCl3, there is a bond polarized pi bond is polarized to this oxygen, and the oxygen get negative charge and the carbon get the positive charge here in the presence of the Lewis catalyst. Then the bond is broken. This bond is broken here. This bond is broken. Then Cl negative temporarily making bond with this AlCl3. Since it is Lewis acid property, then so we will get AlCl4 minus. And since here carbon electrophilicity, the carbon get electrophilicity, here positive charge is formed, being formed here, positive charge is formed here, then the pi electron, one of this pi electron is given to this carbon. This pi electron is given to this so carbocation or electrophilicity of the carbon, then this carbon is making bond with this carbon and forming into CH3CO benzene. So this is ethanol benzene is formed. So this is the main product acyl benzene we say. This is Friedelcraft acylation we say. Now and so I was telling about benzene exhibit electrophilic substitution reactions, which is exceptional chemical properties of the benzene we say. Apart from this electrophilic substitution reaction, benzene also undergoes addition reactions under different conditions, like alkenes I was talking about. So addition reactions the benzene undergoes at high temperature and high pressure in the presence of the nickel catalyst, benzene undergo hydrogenation process. At high temperature and high pressure in the presence of the nickel catalyst, so benzene undergo hydrogenation which is addition reaction we say like alkenes, and forms the compound is said to be cyclohexane. Cyclohexane is a aliphatic compound. Cyclohexane is formed here. That means here is the benzene when react with the hydrogen, 3 moles of hydrogen gas in the presence of nickel and platinum catalyst at 473 and 573 Kelvin temperature, then benzene is converted into, so what is the compound you know, benzene is converted into cyclohexane which is aliphatic compound. So it is nothing but addition of hydrogen atom to the double bond present in the benzene. All the double bonds are converted to single bond in this at high temperature in the presence of nickel and platinum catalyst. Benzene is converted to alkane in this. This is addition reaction we say. And next number 2, so halogenation. So halogenation, earlier we was talking about halogenation, electrophilic halogenation, but here the halogenation in the presence of sunlight. So this is addition halogenation we say. Under ultraviolet condition, ultraviolet light, so means in the presence of sunlight or ultraviolet light, so 3 molecules of chlorine when added to the benzene, 3 molecules of chlorine, 3 molecules of chlorine is added to the benzene, so to benzene, and benzene produces benzene hexachloride, benzene hexachloride, which is called xamaxine or gamaxine, is the compound is formed. So here is benzene when react with the chlorine and formed in the presence of sunlight condition, then we can get so what is the compound, you know, uh, hexachlorocyclohexane. How many chlorine atoms is there? 1, 2, 3, 4, 5, 6. Hexachlorocyclohexane. So it means all the hydrogen atoms. That means here means chlorine attached to the six chlorine atoms attached to six carbon atoms in this. So this is addition of chlorine atom to the double bond is addition reaction we call. Addition reaction. The last reaction of the benzene is that when arenes or the benzene undergoes combustion in the air and it burns with sooty flame, it can produce sooty flame and producing CO2 and H2O. This is chemical combustion of the benzene. So, and by observing this sooty flame, easily we'll identify whether the compound is saturated or unsaturated.